Hi all, welcome to the first part of the video lecture on transaction management. That is your fifth module topic. So what is a transaction in a typical database management system? You can consider transaction as a set of operations used to perform some logical set of work. Okay, so you want to do something within the database, and those set of operations typically you can consider as a transaction. A transaction usually means that the data in the database is being changed because of the activity that you done as part of the transaction. Okay, one of the major uses of database management system is to protect users data from system failure. So inherently what we are trying to say, whenever you are doing this transaction, you should ensure that even though the system failure or something unexpected happens, still the data in the database in the database is to be protected. So DBMS software is supposed to take care of all those things. So whenever it is doing this transaction, it will take care of this. Okay, so accordingly the transaction will be executed. Okay, we will see how it is done. So it is done by ensuring that all data is restored to a consistent state. So this is important. So even if system failure, you can't control it, but if something like that happens, so far what are all the things happen, so that you should be able to restore back, right, to a consistent in the sense correct state when the computer is restarted after say system failure or crash. So the transaction is one of the execution of a user program. So what the user want to do with the database, you can write it as a user program, let it be, you can call it as a transaction. Okay, executing the same program multiple times will generate multiple transactions. So a particular execution of a user program is what we can call as a transaction. If the same program is being executed on a different time, you can call it as a different transaction. Okay, for example, that you are trying to reserve a seat in the railway or airline somewhere, and you wrote a program for that. When the user is executed it for the first time, so that is one transaction. If he is executing second time, means he is trying to initiate something different. Okay, so that time the state of the database, everything changes, so you have to treat it as a different transaction only. So an example is a transaction to be performed to withdraw cash from ATM. So you can see these are all the sequence of steps that we are executing as part of this transaction. So you can say the transaction started here it is completed. So in between you are inserting your ATM card, then you are selecting a language for the for your entire ATM transaction, and the savings account option, amount to withdraw, you are entering the secret pin, and wait for some time to process and collect cash. So this whole thing you can consider as a particular transaction that is happening on the database. Or some other examples okay, you can consider. So typically if you look at any transaction, the major operations are like we have a database on the background, right? So we will try to read or access data from the database. So read, access I can call. So access is actually a general term, whether it is read or write, you can use read access or write access. But anyway, here read in the sense we are trying to access something from the database, or write typically modify the content, right? So a write operation or change operation. And when everything is completed and you want to save the changes permanently in the secondary memory hard disk, so by default whether it is read operation or write operation, these things will be happening in the RAM, okay, main memory. And whenever you are executing this commit, the changes will be permanently made in the hard disk. Okay, so that is what is happening when you execute this commit operation. So one example is given, you are trying to transfer an amount of rupees 50 from account A to account B. So the initial condition is like account A is having 500 rupees and B is having 800 rupees account balance. And so so you are supposed to reduce this 50. So after execution of this transaction, A should contain 450 as a remaining balance, and B is supposed to contain 850 as a remaining balance. So this is what should happen. And you know, when you want to do this modification, so the data needed, like the current account balance of A as well as B, that you have to fetch to main memory. Okay, so that you know, the normal program also by default whenever you are writing it and you are saving it, it is going to reside permanently in the secondary memory, and during execution it will come to the main memory. So here also database transaction, during execution you will fetch the data to main memory and you will modify, and whenever you are executing this commit, the changes will be made permanent to in the hard disk. Okay, so initially this is a case, and your this R of A means read operation you are executing on the data item A, so that you will get this 500 that is being accessed from RAM, because before starting this transaction we assumed that the data block containing A and B or all those things are available in RAM. So that's why you are accessing from RAM, and you are subtracting A by 50 and you are updating A accordingly, and you are writing it back, in the sense now that data item A is going to contain value 450, and similarly you are reading B, it is 800 for the time being, and that value which you read right now, so reading and you are storing it into a variable B, something like that, okay, and you are updating it with 50, in the sense you are adding 50, and this new value you are updating back to B, okay, so write B. And finally, when you are executing the commit, the data in the RAM is taken back to the hard disk, so it is changes are made permanent. So the updated values of the account A should be 450 and B is 850. So this is a typical transaction. Now you saw a sequence of steps in that transaction, right? So once it started, you are reading from A, you are updating A and writing it back. Similarly, B also you are reading, updating and writing back. So all these instructions before commit come under a partially committed state and are in RAM only. So what we are trying to say is, during the execution of commit only, the changes will be made permanent in the secondary memory. So till that, everything is happening in RAM. Okay, so I can say that till the execution of this commit, all those things are in a partially committed state. Okay, something like that I can say. So everything from here to here, all of them are in a partially committed state. Now when you are so when commit is read or being executed, the data is fully accepted and is stored in the hard disk. So if the data is failed anywhere before the commit, we have to go back and start from the beginning. So that is the difficulty we are having at any time. If any failure happened before the execution of the commit, nothing is saved permanently in the hard disk. So you are supposed to roll back to the starting point where you started, and everything you have to repeat, because nothing made permanent so far. So that's why. So this process is something known to be roll back. Okay, you are at any point during the partially committed state, that is from here to here, if any failure happened in the system, you have to move back to the beginning and you have to execute the entire transaction again. So you are supposed to start everything from the beginning, and we can't continue from the current state. This is what we call as roll back. You are rolling back to the starting point. So this is the typical state diagram of a transaction. Transaction begins, and then by default it is in the active state, where it is going to execute a number of read as well as write operations, typically on the different data item which the transaction is trying to access. So whenever the transaction completed, I can say the transaction is ended, right, and that time you will move on to a partially committed state, because still now you are in partial committed state only. Okay, so now when you are executing commit, that time only it will go to the committed state and it will terminate ultimately. I can say that now it is in the terminated state. So this is a normal flow without any system crash or failure. But when it comes to failure, we don't know. It may happen during this active state or in the partially committed state. So before commit, at any time this failure can happen. Accordingly, you are aborting your transaction. The entire transaction is being stopped, and we are moving on to a state called failed state. And from there, the transaction, the entire thing will be terminated. So saying that you are actually aborted everything and you have to restart everything from beginning. Okay, so that rollback is happening on the background. So hope it is clear, right? So these are all different state. At any time the transaction is expected to be. It can be in active state, partially committed state, terminated, or failed state. Fine. So now the question is, whenever you try to execute the transaction concurrently, parallel execution, right? So one normal trivial thing is, like here you have two transactions, a T1 and a T2. What you can do is, you can first execute T1 completely, and then you can execute T2, and it is not going to create any issue, one followed by another. Or you can start with the T2, after finishing T2 you can start T1. Okay, now see, each of this transaction is something doing with the database. For example, if it is something like the same example, railway reservation or something, maybe that Talkal time and all, millions of people or will be trying to reserve some ticket at the same time, right? And that time, that many transactions will be initiated, and that will be happening on the background. Now the thing is that if you are allowing only one transaction to complete after another, within a fraction of seconds, this booking, everything is closed, right? And that time, some user is supposed to wait for all others to finish. Is it something fair to him, right? So he is keep on waiting and he is not getting a chance to reserve the ticket. So nobody will be tolerating something like that, right? So you don't want such a, so this is something called as serial execution, right? So one transaction followed by another transaction. So it's always safe at the database point of view, but the problem is the user satisfaction is missing. No one will prefer such an execution, right? So you keep on waiting for some thousand people to complete their booking, and then only you are going to get a chance to start your booking. But that is not what is happening in our current scenario. Whenever you are trying, even though small delay is there, your some of your operations are happening, right? So you are trying to log in your user id, password, captcha, everything you are giving, and it is opening that page. So that is one step of, or some few steps of the transaction, right? And then you are trying to select the destination, date, time, and you are trying to book. So something is proceeding, and when some thousands of people are doing, for everyone something is proceeding, right? Like this. So this is what we call as the concurrent execution. So everybody is getting a feel that he is the only person who is working with the database, but actually, say thousands or millions of people are actually working at the same time on the database. Okay, but the user, when the user point of view, is not getting a feel like other people are also trying it, but we know that, but still you got it right. So this is something called as concurrent execution. So parallelly we will allow each and every individual steps of the transaction, like it will interleave something like that, so one after another. So t1, so one or two steps it will execute, then t2 one or two steps, and t3 like that, then again come back to t1, so that no one has to wait for one person to completely finish his transaction. In between, everybody will get a chance to do it, right? So that, so this is something that is happening in many situations, right? So not only in this reservation, you can quote a number of examples. So several problem, but it is not at all a safer thing. Many people are trying to access database concurrently. Definitely some kind of issues you can expect, right? So one person is writing something, another one is reading it, but the commit is not happening. In between, if any failure happened, like that, many things you can think about. Some of the standard problem we will see now. So because of these problems, we have to allow this concurrent execution in a controlled manner. So the question is, why we have to control this concurrent execution, or why concurrency control approaches are needed. So several problems can occur when concurrent transaction execute in an uncontrolled manner. So if we are not giving any control, so simply you are allowing many transactions to proceed in parallel, definitely there will be a number of issues. And some of this problem, especially standard problem, is what we are going to see now. So for that, we are assuming these two transactions T1 and T2 for explaining those issues. So to what T1 is doing, T1 is reading something from the data item X, and he is subtracting some quantity N from X. Something like what happened. So some 50 rupees is being transmitted from account A to account B, something like that. So some N is being subtracted, and he is reading another data item Y, and where this N is being added. Okay. And similarly, what T2 is doing, T2 is reading the same X, right? So this is the issue. So same data item when two people are accessing in a concurrent way, will it create any issue? So that is what we are looking at. Okay. And he is also modifying this X with some M. Okay. And let me take an example also. And will tell you what will be the result if it is executed in a serial way, which is the safest way, right? So what I can assume is, like, suppose the initial value of x be, I'm just taking some value, say 100, and for y it is 200. Okay, now let me take this n as say 50 and m as 30. Okay, I'm just taking some random values, and let me see the serial execution result. Serial execution in the sense, there are two cases. So one thing is like a T1 followed by T2. So first we are executing T1, and let's see what is the result. Okay, T1 is executed first. So what T1 is doing, T1 will read this x as 100, and he will subtract that 50, and it is returned back. So T1 will modify. Okay, if I'm writing like this, it will create confusion. So what T1 will do, T1 will modify this x as 50 after execution of first 3 lines, and then again he is continuing, is reading y, and this y he is updating with this n value, same n value, so that y will be updated to 200 plus 50. Okay, the same quantity is subtracting from x as well as adding to y. So 250, y will be updated to 250. Now after this execution, our T2 is executing, right? So first T1 completed, after that T2 is executing, and that time what T2 will be reading? T2 will be reading x as the current value of x, because after completion of T1, after maybe commit everything, it is not written. So assume that T1 completed and it is committed also, so that when T2 is executed followed by T1, it will be getting the latest value of x as 50, and that 50 it is adding with the 30, that is that m, so that x will be modified to 80. So after the complete execution of the program, if you look at the variable x and y, you can see that the latest value of x is 80 and y is 250. Okay. And now let's see another execution. Say this is one way, and another one is, of course, T2 can start first followed by T1. So anyway, both are fine for us. Okay, and it's not a concurrent execution or non-serial execution, just serial, one after another after. So that here T2 is started first, and see T2 will be reading x. So now this x means this original value. Okay, you have to take this 100 and 200, and these are all the initial situations. This is case 1 I am talking about. This is case 2, another way of serial execution. So the T2 will be getting x as 100, and with that 100 he is updating some 30 value, so that x will be updated to 100 plus 30, that is 130. Now followed by T2, T1 is executed. So what T1 will do? T1 will initial condition is same. Okay, so this is our initial condition which I assumed. Okay, so you have to take the same initial condition for both execution. Okay, and so what T1 will do? T1 will read this x. So now it will be getting that 130 updated value, because T2 finishes and it committed also. Okay, its commit is not written here, so assume that it is committed also. So that T1 will be reading x as 130, and after that T1 will subtract 50 from 130, so that x will be updated to 80. Fine. 130 minus 50. Now it will be reading y value, and y value is 200 only, and then it is adding y with this 50, so that 200 updated to 250. Now you can see that whether T1 follows T2 or T2 follows T1, the final result is same. In the database, the variable, the data item x is updated to 80 and y is updated to 250. So this is the speciality. But if I am getting something different, and that is because of the concurrent execution or uncontrolled concurrent execution, and we are going to see certain popular problems out in that direction. Okay, see, this is also a non-serial execution that you can see the same operations only, T1, T2, but what happened is this vertically we are taking the time, and what we are trying to show is, instead of executing T1 followed by T2 or T2 followed by T1, we are allowing them to execute in a concurrent manner. So that in T1 I am allowing 2 steps, say read x and update x, and after that I am allowing T2 to do read x and update x. Then I am doing T1, I am continuing T1 with write x and read y. Then I am executing on intermediate step from T2, say write x. Right, again I am coming back to T1, I am allowing this. So anyway, our original thing only, but in a serial manner I am in a non-serial manner, in a concurrent manner, I am allowing the execution on after another few steps from one and another, like that it is proceeding. Okay, so now it is not a serial execution. Let's see what is the problem. The first problem that we are going to see is what we can call as the lost update problem. As the name says, some of the update done by someone is lost. Okay, so that about it. So it's a very easy to understand problem. Let's see this example itself. So here, hope you remember the values, initial values. X is 100, y is 200, n I assumed as 50, m as 30. And let's see what is happening here. So here x is read by T1. So this is what happened initially. So that x will be, T1 will understand x as 100. Okay, so it will be reading it as 100. Then x is being updated. Okay, so that now this x will be updated to 100 minus 50, that is 50. So this is our current value of x. this update is being done by T1. Okay, now before completing further, this is just update happened in a variable, but that in the sense the actual data item in the database is not modified, so that you have to note down. So X is updated but it is not modified, so this is our database content. See what is happening. So in a local variable you taken this X and you updated it, but you didn't return it back. So if you are looking at the database, it is 100 itself, so this update is not saved, okay, or it is not reflected into the variable X. Okay, so this is what I am trying to say, so keep that in mind. So in between I interleaved to T2 where I am reading X. Now can you tell me which value of X will be read by T2? Okay, at this point, can you tell me which value is read by T2? It is going to read this initial value only, because in the database, from the data variable X, I am doing this reading. This update actually happened in a variable maybe used in the program. It is not updated to or reflected back to the X. So whenever this T2 is trying to read, it will get this 100 value only, because this 50 is not reflected here in the database. After this write operation only that will happen. So this is what I am trying to say. So now what this T2 will do, T2 will add with this 100 that M value, which is 30, so that X will be updated to 130. Okay, now it will come back to T1, so that it will execute this write operation. Now what is the value of X? It is 50, and it will execute this write operation. As a part of this write operation, this 100 will be updated to 50. Now it will read y. Okay, let it read that y value to 200. Okay, now see, when you execute this write item, can you tell me what is this X? This is something local to this transaction T2. For transaction T2, this X value is now 130. So what this T2 will do is, it will irrespective of what is there in the database and all, or what is done by T1, T2 will simply update this value to this 130, because it is executing this write operation. You got it right. Now see, after finishing, y will be updated, and in this case there is no big issue with y. Okay, so the problem is actually happening with X. Okay, so after the execution, the variable X is updated to 130, but for the correct execution, for the serial execution, whether it is T1 followed by T2 or T2 followed by T1, what we are expecting is a value of 80 for the variable X, and you are getting a wrong value here. And this wrong result X is has an incorrect value, or wrong or incorrect value, because what is the reason? It's updated by the X is being updated by X, but you are not getting that update, right? It's actually lost. Okay, lost in the sense it is being overwritten. So here it is updated by 50, and which is being overwritten by T2 or something. Okay, you got it right. So this update done by T1 is lost, and or you are not able to get this update. Okay, so in between you started reading. Okay, so the update is lost, so I can call it as lost update problem. This is one possible scenario that you can expect when it comes to a incorrect uncontrolled execution of a schedule like this. Okay, so this allowing multiple transaction like this is what we can use a different term called schedule also. So how different transactions are interleaved. Okay, it is like if it is a serial schedule, one transaction followed by another one, like that. If it's non-serial schedule, in a concurrent way we will schedule the transaction. So that is another terminology you can use. Anyway, this particular schedule is suffering from the lost update problem because of the uncontrolled execution of the concurrent operation. We will see how to solve this everything. Okay, so now you are understanding these as different problem that can happen. Now another one is the temporary update problem. Again we can take an example and see what it is. See the same example. The initial value of X, hope you remember, it was 100. That is read, and it is modified to say X minus n, in the sense X will be updated to 50 in the local variable, and that is permanent in the secondary memory also. So if you are looking at the variable X, initially it was 100. Now it is completely updated by transaction 1 to 50. Okay, fine. Now after this I am reading it, so definitely transaction T2 is going to get a value of 50, there is no issue, right? So 50 plus 30, and it is writing it back also, so that after execution of this step, 50 plus 30, it will be 80. So the correct value of 80 is being updated in X. So you can't see any issue here, right? And you are proceeding with the read way and you are continuing. But the issue is something like so we have to assume a situation. The transaction T1 fails somehow, okay, we don't know. So in between, the transaction T1 fails at any intermediate step, or during the partially committed state it fails, okay, before committing it fails and must change. So whenever such a failure is happening, what we will be doing is we must change the value. So we will roll back, right? We roll back in the sense everything we will roll back. So as part of this failure, at any point whenever this transaction T1 is failing, so what the transaction will do is it will make this 100, transaction T1 updated this X value to 50, right? So what was the initial value of X? It is 100. So it will roll back X to the point before starting this transaction. So before committing, it failed. So whenever you are failing at any intermediate steps, you are supposed to roll back, in the sense all the changes that we made, you have to what I can say, you have to erase from the database, and you have to reset it back to the initial value, and the initial value was 100, right? So even though it is being updated by T2 to 80, so that is how it has happened. So T1 will roll back to this 100. So again problem, right? The transaction T1 is going to change the value of X back to its old value. Meanwhile, T2 has read the temporary incorrect value. So in between, what is being read by T2 is something like 50, and which is an incorrect value. It is not saved permanently in the hard disk. Yeah, that is going to create the issue. Okay, in between there is a failure, and when you are adding it, you are updating everything with respect to that X value is 50, and which is just a temporary update in our example, because T1 is not committed. After the commit operation of T1, if you are proceeding to T2, you can say that the update is permanent. Okay. Serial schedule, it is happening like that. The transaction T1 followed by T2, in the sense T1 will complete everything and it will do that commit also. If there is any failure, it will roll back, and there is no issue because T2 is not even started it. Okay, so with the serial schedule, it is not going to create any issue. But if it is a concurrent execution like this, definitely the value read by T1 is a temporary update, read by T2 is a temporary update made by T1, and that update is no longer valid at this point, because when that T1 fails, it rolled back everything back to that 100. T1 says, I don't know what is this 50, because it simply that update is lost, right, for T2. Yeah, so this is another issue. So you are supposed to sometimes you may answer it independently also, like what is temporary update problem loss. You can take an example like this and you can explain. Okay, so the problem is like meanwhile T2 has read the temporary incorrect value, temporary update made by T1. So that is the issue. Now one more issue that we can think about is the incorrect summary problem. Again, let's take some example and explain. So here the transaction T1 is taken as it is, the same example before, and T3, one new transaction is being introduced for explaining this concept, say T3, and let's see what this T3 is done. It is having a variable sum, and it is reading a data item capital A. We don't know, it is not here anyway, and that data item value which you read right now, you are updating to the variable sum. So this is what is done by this. And it is so basically it is doing some kind of addition. So where every data item, so first it started with the updating that sum with the A, then again it will read some other data item and you will add it to that sum variable, so that finally you are going to get some sum of all values of the data item, something like that. Now in between, you are as part of accessing all data, you are accessing your X also, and you are updating that sum variable with this X also. So you are adding the current sum with this X, and you are accessing this Y also, right? So because just like any data item, X and Y are two data items, you are simply adding all the data items together into a variable A. So first data item you are added, and maybe second another data item B, C, D, like that you are adding, and at some point you will be adding the data item X and Y also. And this is how you execute it, because here this transaction 1 did some update on x, and then you are taking that x and you are updating, and but y is yet to make that change, but before that you are reading the value of y, so definitely you will get the old value of y and you are updating. So yeah, this is how it is proceeding. And let's understand the problem with the same example we taken. Let's assume that the initial value of x and y are like 100 and 200. Same value we assumed before also. Okay, and we will see what is happening. So here what this T1 is doing, let's first see the effect of the serial execution, because now we have a third new schedule. So we are trying to see what will happen if it is executing like a T1 followed by T3 or T3 followed by T1. Anyway, both are fine. Okay, if it is something like a T1 followed by T2, and I'm not talking about this particular schedule, I'm talking about the equivalent serial schedule, and then only we can understand what is the problem here, right? So if this is the equivalent serial schedule, you can see T1 then T3. So T1 will update x to this 50, and it will be writing it back, so that x is subtracted, and here y is 200, so this will be 250. You are adding that x, right? So these are all the values of T1 and T2, so that when you followed by T1, if you are adding this, you are executing T3, what will happen? What T3 say? T3 will keep on adding all data variable. I don't know what is there in sum. So at this point, suppose the sum variable is getting a sum of 1000, for example, I'm just taking. And if that is the case, then after with this 1000, you will be adding the x value and y value as it is following T1. X is updated to 50, so here you will be adding 50, and y is updated to 250, so that the sum will be added with the so if it is 1000, the sum will be updated to 1000 plus 50 plus 250. So sum is equal to sum plus 300, like that. Let me write, I don't know the previous value of sum. If it is 1000, it will be 1300, something like that. So if the execution is like a T1 followed by T2, let me say I'm just removing it because same example I have to update. I can see that the variables, finally the variable sum is updated to the sum so far. I mean, you are adding all data item, and the current sum I don't know, and after execution of these two lines, the sum will be updated to x plus y. X plus y in the sense which is being updated by T1. So T1 subtracted 50 from x and added that 50 to y. So after adding x and y together, it will just increase the sum to some 300 value only. That's 50 plus 250. Same thing will happen if it is T3 followed by T1 that time also. So now T3 is started first, okay, so that it will not get the update by T1. So here this 250 is obtained by adding 50 plus 250. 300 you got like this. But here also this sum will be updated by 300 only, but now this 300 is the initial value of x and y, that is 100 and 200. Those values only this T1 T3 will be getting. I'm talking about T3 because T1 is not finished. Here after T1 you are executing T3, that's why you are getting the updated value 50 plus 250 for x and y respectively. But here you will get the value, x value as 100 plus 200. Anyway, both are updating this sum with the value of 300 only. But how this 300 is obtained? Here it is 50 plus 250. Here it is 100 plus 200, right? This is the update made by T1. Here this is the initial value of x and y because there is no update done by T1. And following this, T1 will do this modification on x and y. So that will happen. So, but we are just focusing on what is the final summary or something that is happening in the variable sum. Okay, so let it be summary or sum or whatever it is. Okay, we are just focusing. So this is about the serial schedule. Now let's see what is going to happen in our example. I mean the non-serial schedule. So let me use this color and the updates. I'm writing it clearly here. You can see here x is read, so 100 is read by this, and then it is x is modified to 50 and x is written back also. So after execution of this, the variable x is modified to, after execution of these three lines, the x is updated to 50. And when you are asking this T3 to proceed these two lines in between, T3 will be reading x as 50 because 50 is made permanent, right? In the sense you are writing it also. Okay. Otherwise, I will not get this 50 because in the local variable only it is updated. But now it is updated in the original database variable also. So you will be getting it as 50, and this 50 you will be adding. So that sum will be updated to sum plus 50. Okay. and with that value again you are reading y. Now when you are reading y, see the y update by t1 is not started yet, so before that you are reading y, so that you will be getting the old value of y only. Y is actually updated to 250 by t1, but that change you will not get because that is going to happen only. So when you read y here, you will get y as 200 only, and then you are adding with the previous sum. So the sum so far is actual sum plus 50. Now with sum plus 50 you are adding 200 also, so that this sum will be updated to the sum of all values, say a b c d etc, plus when you add this x and y, it is like 50 plus 200. That update only will happen. So sum will be updated to sum plus 250. See, this is an incorrect value, right? So here the correct value of sum should be 300. Whether you are following T1 followed by T3 or T3 followed by T1, when it comes to serial schedule, serial execution, you have to modify that sum with the sum so far plus 300, which is the update of x and y. But when I am executing like this, I am not getting that correct update, or I can say that the summary made by transaction T3 is incorrect, because also the problem is in general called as incorrect summary. So here it is summarizing a variable with the latest value plus 300. Here it is summarizing with the 250, like that. So T3 reads x after n is subtracted, like after n is being subtracted from x and before n is being added to y. So in between you are reading T3. So that is actually creating the issue. So it will lead to wrong summary. So you can see that the actual summary should be something like the actual summary should be something like 300, and the summary which I am getting is 250. You can see that this result is from the actual result I am getting a result which is off by some 50. And what is this 50? The value of n. Okay, so something like that is happening in our example. So in general this problem is known to be incorrect summary. Okay, so that about the 3 problems that I explained with suitable examples. You can also do the same: the lost update problem, the temporary update problem, the incorrect summary problem. Now one more problem, that example is not there, but you can visualize how this problem is happening: the unrepeatable read problem. In the sense, if you are reading the same data item again and again, you are expecting the same value for it, right? But in between it may be updated by someone else, so that the read that you made recently is not going to repeat. For example, you are trying to reserve, the same example I am taking everywhere, some ticket somewhere, and initially at 10 o'clock you read the database, or you read the you checked the current reservation status. You saw that there are some 100 seats left, and after some 1 hour you are coming back, you are reading again, and it is showing that 50 seats left. Then you will be thinking, why when I am reading it again and again, the read value is not repeating actually, but it is something I can call it as a problem. This is something, it should happen like that, okay? But from the user point of view, user may be wondering why that repeat is not and why that read again and again is not giving me the same value, why the value is not repeating. But actually as part of concurrent execution, you can't expect this repeatable read, so the read is always unrepeatable, okay? So that also you can highlight as a problem. But let me tell you, as part of concurrent execution it will be there, okay? But in non-serial in case of serial schedule, it is not going to happen. Okay, so something like that, you got it, right? So another problem that may occur is called unrepeatable read, where a transaction T reads the same item twice and the item is changed by another transaction T dash in between. Okay, but the user is supposed to be aware or updated in that way, then it is not going to create any issue otherwise, okay? I mean, in certain situations this is something mandatory, without that you can't proceed, but in certain situations actually you don't want the read to be unrepeatable. That also can happen, but the example I taken is something favoring it, okay? Hence T receives different values for its two read of the same items. This may occur, for example, if during airline reservation or something a customer inquires about the seat availability and he got a value, and after some time again when he inquires, he is getting a different value, okay? Yeah, this is also something that you have to take care. So if something like that is happening, is it happening in the right way, like that? So that about it. Let's conclude with one more small topic. So keep all these problems in your mind. So why we need concurrency control? Because there are many issues like lost update temporary. So last one I'm not calling it as an update. The only thing is the users using it should be aware about it. Then that problem is solved, okay. But other things, other three things, it's very crucial because you don't want such unexpected result. You always need the result to be expected, like what is happening in the serial schedule, that is something should be produced by non-serial execution also. So how you will check it, that we'll see in the next video lecture. But in between, before concluding, so we saw transaction and what about its concurrent execution and many properties of it, and now some of the standard desirable properties of any relational database transaction is what is listed here. So let me tell you the word relational database. We are just talking about relational database only, but there are other database concepts also, like not only SQL, NoSQL and all, and they are not following this ACID property. ACID properties are something particular to relational database, okay. ACID, that is expansion, you can expand it like A for atomicity, C for consistency preservation, I for isolation, and D for durability. So whenever you execute any transaction, you ensure these four properties which are desirable for any relational database transaction, okay. So it's very easy to understand from the word itself. So what do you mean by atomicity? Whenever you execute any transaction, it should be executed as a single atomic unit. In the sense, in between a failure happens, what you will do, you have to roll back to the beginning, okay. You can't treat the individual steps inside a transaction separately, and you are saying that there are 10 lines in a transaction, I executed 5 and then there is a failure. I'm not doing anything because 5 are executed and then again 5 more are yet to execute. After restart, I am executing the remaining 5. That is not good, okay. That is not going to work at actually. So if there is any failure in between, you are supposed to roll back to the starting state and you have to continue from the beginning. So entire transaction sequence of operations should be treated as a single atomic unit. So in between, some are executed, some are not executed. That kind of a state is something that we don't want, okay. So that is atomicity property. A transaction is an atomic unit of processing. So the entire transaction, all the sequence of steps should be treated as an atomic unit. That means further in between there is no division. So it should either be performed in its entirety, it should be completed and committed completely, or it is not performed at all. Please roll back and go back to student. So this is something that we explained already, but we are giving a name. So this is the first property, say atomicity. That's all clear. And now again, consistency preservation, right? The correctness. At any time when you do anything into the database, you should always ensure that the database is being changed from one consistent state to another consistent state. Consistent in the sense with respect to the initial value of data item and what are all the changes you made after execution of the transaction. You are expecting something, right? This has the correct result, consistency. So that result only you should get. But you know, if you are executing wrongly in an uncontrolled way, especially when it comes to concurrent execution, you can't ensure this. So by default, the database management system software is supposed to ensure all this property, and we will see how each of them is being ensured, okay. So right now we are understanding everything else. We don't know how to solve these issues. We are expecting like these are all the desirable properties, and how it is to be achieved we will see later, okay. So that is consistency preservation. So a transaction should be consistency preserving, meaning that if it is completely executed from beginning to end without interference from other transaction, it should always take the database from one consistent state to another. Assuming that before execution of the transaction, database in a correct, valid, consistent state. After execution of the particular transaction also, the database should result in a correct, valid state. So this is what is our requirement. The database change, after every transaction, database state will be changed, and that changed state should be a consistent state like the previous state. Now isolation, of course, whenever we have a concurrent execution, each individual user should be isolated completely, and he should get a feel that he is the only person who is working on it. But actually many people are working on it, okay. So that isolation should be ensured. What is done by one person should not disturb other person before committing, okay. So if he made the changes permanent, okay, let the other person also get that change. Otherwise it should be isolated from one to another. The previous problems are because they are not isolated. In between few steps you are switching to another transaction, and that time that transaction is actually depending on the changes that you made in a partially committed state. Okay, so that is actually creating issue that we don't want. Okay, isolation means a transaction should appear as though it is being executed in isolation from other transaction. You don't know, like even though other people are executing in parallel with you, you should get that feel that you are isolated from others. Even though many transactions are executing concurrently, that is, execution of a transaction should not be inferred by any other transaction being executed concurrently to this. Okay, this is the isolation property. Now, one more property that we have is the durability or permanency that I already told you. Whenever you are executing commit, every change is made permanent in the secondary memory. If things are not moving on to secondary memory and you are doing changes everything in main memory and you are just leaving it as it is on, main memory is volatile in nature. Once you turn off the system and you come back, whatever change you've done so far, it will not be available. That should not happen. You have to ensure that each transaction is going to make the changes durable or permanent. Okay, so the changes applied to the database by a committed transaction. We don't want the changes to be permanent for a partially committed state. We are talking about a committed transaction which is complete, full. So those changes made by the committed transaction must be persistently available in the database, should persist in the database. These changes must not be lost because of any failure, so that you have to ensure. So these are all the 4 property. Atomicity, a transaction as a whole is an atomic unit which should execute completely or not at all. Okay, clear. Consistency, always you change the database from one consistent state to another consistent state. Isolation, when you execute many things parallelly, one should be completely isolated from other. That concurrent execution, it's negative sides that we see so far, that we execute, we saw some problems, right? So those things should not be there. All are trying to say that only. And durability or permanency, all the changes that you made should be permanently available in the secondary memory. Okay, now in the next video lecture we will be seeing how those concurrent execution which is creating many issues, how we can solve it, and also how we can ensure these asset properties in general. Okay, so that about it. Thanks for watching. Doubts, if any, you can clear by messaging me. Okay.